So in section 2.9 in subtracting integers, we start with the language of subtraction. And we use all of these different languages or phrases to talk about subtraction, and it can be confusing for students because subtraction is not commutative. They likely think it is, and depending on the language we use, it could reverse the order. So minus language would be 5 minus 3. Subtracted from language, well, subtract 3 from 5. So notice that order is reversed. Less than language, we want to talk about this as 3 less than 5. Okay, and also note 3 less than 5. They can easily confuse this with 3 is less than 5. Okay. So the is telling us that there's an inequality relationship, a relationship between two numbers, where 3 less than 5 means that we're taking 5 and subtracting 3 from 5. Okay, so notice they're very similar, and I can almost guarantee one of your students, and when they are given this problem in Math AS, will write a symbol like this. Okay, so you want to bring that to their attention, that this is talking about a relationship, just like when we talk about equations later, 3 is 4 times 7. The is talking about a relationship, where this less than is talking about the operation of subtraction. Okay. And then decreased by, so this would be 5, decreased by 3. Okay, so we want them to know all of those different ways of writing this. It's really good to start with positive numbers. They also have an example with negative numbers, but when they have trouble with this later, I ask them to think about positive numbers. So if they say, let's do 6 minus 7 is 7 subtracted from 6. Many of them will want to say that this is 1. They want to give it the positive value, and again, it's because they work with whole numbers for so long, okay, that when you reverse the order, they want it to be a positive number. So I'll give them something with smaller numbers where the answer isn't negative and ask them to draw a connection, like 10 minus 4 is 4 subtracted from 10. If you ask them what 4 subtracted from 10 is, they'll say it's obviously 6, and then you can have them try to connect these ideas to see how the phrasing works when you have negative numbers. Okay, so spend a little time on that. Okay. Here's subtracting integers with chips. Okay, so this is broken into positive minus positive and negative minus negative. So let's start with that. Those are the easy ones. Let's do 5 minus 3, negative 5 minus negative 3. Okay, so we have 5 chips. We're going to think of this using the takeaway model. You can also use the comparison model. And I think I may do that. We'll check in a second. So we have 5 chips. We want to take away 3 positive chips. When you take them away, you're left with 2 positive chips. Then 5 negative chips. We want to take away 3 negative chips, and we're left with 2 negative chips. Okay, so drawing connections between the signs being the same in subtraction and showing how the model is very similar, it's just opposite signs for the chips. Now part 2 has 3 different types. Okay. So starting with this example where you have 2 positives but your result is negative. So this one's a little bit different for them. So we want 3 minus 5. So we have 3 positive chips and we want to take away 5 positive chips. But we don't have 5 positive chips to take away. So this is where we use that idea of the plus and minus pairs. We want to take away 5. So I'm going to add 2 positive chips, And if I also add 2 negative chips, then this, notice, is equivalent to 3. So this is another representation of 3. It's not the simplest, but this representation allows me to take away 5 negative chips. Okay? Once you do that, you see you're left with negative 2. The next problem is 5 minus negative 3. So we start with 5. And now we want to take away negative 3, but we don't have any negative chips. So I need 3 negative chips. So I'll add 3 negative chips. But to make this equivalent to 5, I'm also going to add 3 positive chips. So notice this simplifies to 5 because these are all 0 pairs. Okay. Now I can take away the 3 negatives, and the result is 8 positive chips. The last type is negative 5 minus 3. Okay. So now we want to start with negative 5, so 5 negative chips. 1, 2, 3, 4, 5. And we want to take away 3 positive chips, but we don't have any. So we'll add 3 positive chips and 3 negative chips. Now we have 3 positive to take away, and we're left with negative 8. Okay. And notice the symmetry between 5 minus negative 3 and negative 5 minus 3. They have the same underlying structure, okay, where we're adding the ones we need to take away, which makes the sign we're starting with accumulate. So here we had 5 positive. Taking away 3 negative gave us 3 more positive, or this is equivalent to 5 plus 3. Okay. Here we started with 5 negative. We wanted to take away 3 positive. And I'm just thinking sometimes this is tricky for them. They think of this 3 as a negative. Okay, and so we ended up adding 3 positive, which adds 3 negatives. We take away the 3 positives. We accumulate 8 negatives. So you can try to have them compare some of these results with addition and subtraction and with each other. The more they compare and contrast and see patterns, the better understanding they'll have. So let's scroll down a little bit. Okay. In this video, we connect addition and subtraction. Okay. This is incredibly difficult for them. Okay. So the fact that we're using here is that subtracting an integer from the number is the same as adding the integers opposite to the number. And this is definitely useful. So we've shown them the subtraction rules, but especially when we have, I don't know, 15 numbers to add up and the signs are all different, which we'll see in the next section when we learn about associativity and commutativity. We might want to write these as all positive numbers, or excuse me, as all addition, all of the operations, and we want them to see the connection. So here we want them to write 4 minus 7 as addition. Okay, so typically I've seen this so many times that they just change the subtraction sign to addition. Okay, so I suggest you challenge them and ask them, well, is 4 minus the same as 4 plus 7? Because we want to write an equivalent problem. Okay, they need to have the same answers. Okay. So I stress that the first number stays the same, change subtraction to addition. This number is positive, and I'm going to make it negative. Okay, and again, it's best if you first connect this to the chips and show them, well, when we wanted to take away the 7 chips, we ended up adding negative chips. Okay, but they need to have this skill, and here it's just the introductory part. We're really going to use this in the next unit. So it's good to introduce it here. Hopefully they'll begin to get an understanding of it, but it'll get more solidified in the next section. Okay, and then 6 minus negative 2. I really try to focus on that we're changing it to adding the opposite. So instead of doing that thing, they call it chop chop or something like that. Okay. So instead of writing that, okay, because they love chopping things. They absolutely love this. But we want them to see that we're changing the operation from subtraction to addition. We're changing the sign. This is negative. We're changing it to positive. Also, when we have these two plus symbols, this one's a plus, this one's a positive, it can be confusing for them. Also, this is the one they're good at, is when you have a negative and a subtraction and a negative and canceling them both. Here they don't know what to do with this. So we're going to try to use a consistent method for rewriting as addition. So 6 plus 2 is 8. Here I'm not going to go through this too in depth, just kind of tell you the idea. Okay. Use the standard algorithms to solve addition and subtraction problems below. So it's the same two numbers. They're more than single digits. Have them add them, have them subtract them. And then here we want them to see we have all these different types of problems, and the results are either going to be the sum, positive or negative, or the difference, positive or negative. So we want them to see that connection, that all of these are in completely different problems. So here we'll want them to see it's plus 2 negatives, so we'd use addition and the result would be negative. Okay. Here it's a negative and a positive, so we subtract. 308 is bigger and it's positive, so the result is positive. Here we subtract. 308 is negative, so the result is negative. With subtraction, you can either have them rewrite this as addition. Okay, sometimes that's easier for them. Or you could think about a positive and we're taking away a negative. Since this negative that we're taking away, that would be adding more positive chips. And again, I still think that's too complex when the numbers get bigger. And then that would give us a positive result. But they might want to switch these all to addition, and that'll give them some practice rewriting as addition. And then they do the same thing. Oh, that's a U-try problem. Okay. So in the next video, we'll talk about multiplying and dividing.